Hello students, good evening all. So welcome back to our classes. In our previous session we have finished our chapter binomial theorem. So in our today's session we are going to start a new chapter, as I mentioned earlier, sequences and series. I think you guys have already heard about this series and all. Right. So in that, you might have learned about arithmetic. Some of you might have learned about geometric. Right. So geometric progression, arithmetic progression. So these and all we have. Some of you might have familiar because we have learned those things in your 10th standard. Some of you might have learned in your 9th. Right. So we'll be having those two. Along with that, we are having some more advanced concepts in our chapter of sequences and series. Right. So before starting our today's session, so first we'll just have a quick overview of the concepts and topics that we are going to cover in our today's session of sequences and series. Right. So first we'll just have an introduction, like what is the basic definition of the sequence as well as series. So it's a introduction part here, like the definition, the representation and all. And once we are done with the introduction part to our sequence, then we'll be seeing the types. So in which we are going to see the finite as well as the infinite sequences. So here we are starting with the definition of sequence, and then we are jumping into our types, where we are going to talk about the finite as well as the infinite sequence. And then we'll be having a typical rule and formula. How can we formulate this sequence? Right. So what is the rule which we can follow and what will be the formula? So it will be varying for one sequence to another. Right. So for example, here we'll be going to see with respect to examples. So no need to worry. So we are going to see the rule as well as the formula here. And then we are going to see the sigma as well as the pi notation. So when it comes to our what we'll say series, the sigma notation will be very, very important, because series is something to do with the sum. So yeah, sigma will be important, sigma notation, when we are talking about the series part. So when we are talking about the series part, as well as we should be familiar with this pi notation also. So as in combination, we are going to see this sigma as well as the pi notation along with the properties related to these two notations. Right. And next come this arithmetic progression. So before discussing this arithmetic progression, we'll be just seeing what is this series also and the representation of it. And then we are going to look over the arithmetic progression here. So I hope you guys are already familiar with this arithmetic progression. Right, so we'll just have a look over in detail what is this arithmetic progression. And in this particular arithmetic progression, we'll be having the general term, common difference and all. So we are going to have a quick discussion over the terms and every terminology which is related to our arithmetic progression here. So mostly we can say in our today's session, we are all into the basic introduction part to our series as well as sequence. And then we are going to discuss our arithmetic progression and the terminology and the things related to the arithmetic progression in our today's session of sequences and series. So I hope you guys clear with this. So I think we can start our session. So as I mentioned, we are going to start our session with the definition of sequence. So you, by hearing the name itself, some of you might have an idea like what is the sequence called to be. So in your own words, so you can let me know what you're thinking about this sequence in your own words. So if anyone can give me any answer, that would be great. So a sequence is nothing but it can be defined. So it's basically a simple ordered collection of things. So in a simple easy words, we can say that sequence is nothing but an ordered collection of things. Right. So here things in the sense we are here talking in terms of numbers. So usually there will be numbers. So we can say ordered collection of numbers. Right. Or we can say in another words, a set of numbers arranged one after another. Right. So this sequence, right. So the basic definition here is nothing but simply ordered collection of numbers. Right. So the numbers will be ordered in a particular manner one after another. Right. So some cases in sometimes this sequence can also be referred as a progression, which means we can say a progression is nothing but a sequence. Right. So there is a condition to there is a condition here to call to be a sequence. So what is that condition here? When we are talking about a sequence, then the minimum number of terms which should be present should be 3. So maximum can be any number, right? It can go until infinity, but still when we are talking about sequence, there should be a minimum. If I'm writing some 5 comma 10 and I'll be calling this to be a sequence, whether it's right or wrong, it's absolutely wrong, right? Because to become a sequence, the terms which should be present in that will be minimum how many number? So minimum 3 terms should be there in order to call that set of numbers, that set of collection as a sequence. Right. So this is the finest condition which we have to keep in mind while dealing with this sequence. So as in flow, sometimes if there are 2 terms only, we'll just consider it as sequence and we'll be going that. But it's absolutely wrong. So to consider a set of numbers, a ordered collection of numbers to a sequence, the minimum number of terms should be present in that particular sequence will be 3. So maximum it can be any number. So here you can see the example of a sequence here 0, 7, 14, 1, 4, 7, 10. Right. So here you can see 7 plus 7 plus 7 here plus 3 plus 3. Right. So here we are having minimum number 3. Here minimum number terms 3. So absolutely these two are examples of sequences here. Right. So now as we have seen the definition of sequence, so now let's categorize the sequences here. So as I mentioned, we will be discussing 2 types of sequences. One is a finite sequence and the other is an infinite sequence. Right. So a sequence, so by adding these 2 words finite and infinite absolutely gives the exact meaning of those sequences. Right. So in your sets chapter also we have dealt with finite set and infinite set. So same typical condition and same definition will be applicable for the following types of sequences also. Right. So here what is the definition of this finite and infinite sequences here? A sequence containing a finite number of terms is called a finite sequence, which means the number of terms should be countable. Right, so the number of terms which are present in that particular sequence can be countable. That means it will be a finite number. Right, so that particular sequence is called to be a finite sequence. So let's have a quick example here. So 1, 3. So if this is my sequence, so first what is the condition we have to check to call these set of numbers to be a sequence? So 1, 2 and 3. So minimum number of terms should be 3. So this is absolutely a sequence. Right. So now we have to categorize this sequence whether it's a finite one or infinite one. So how many number of terms are there here? 1, 2, 3, 4 and 5. So here the number of terms should be countable, which means finite number of terms are present in this sequence. So this particular example sequence is called to be finite sequence. Right. right? So whereas infinite will be quite opposite to it, right? So if the sequence contains a infinite number of terms, it is known as infinite sequence. So what do you mean by this infinite word? The word infinite, what it actually indicates here? So the word infinite indicates that it never ends. That means there is no end for that sequence. That means the number of terms which are present in the sequence is uncountable. Right. So let's have an example here. So you can see the first example, 1, 2, 3, 4 and so on. So can you count and tell me how many number of terms are present in this particular sequence, in this particular example which is given here? So you can count 1, 2, 3, 4 and the other? You cannot. So you'll be saying infinite. Right. So infinite number of terms are there. So obviously it will be, so this sequence is called to be infinite sequence. And the same manner you can see the next example also here, having the terms 20, 25, 30 and so on. Again it indicates infinite number of terms. Right. Which means these two sequence, so these two examples will be coming under our infinite sequences. Right. So far what we have seen, we are talking about sequences, the definition of sequence we have seen, and the types of sequences we have seen, finite and infinite sequences. Right. So now let's move on to our next topic, that is rule. Right. So there will be, so when you are writing any sequence, it's obvious that it will be following a particular rule. So for one sequence, there will be one typical rule. Using that rule, where the other terms in that sequence will be building up. Right. So a sequence usually have a rule. So it's obvious that for every sequence, there will be a rule. Right. So on basis of that rule, right. So basing on that rule of which the terms in the sequence are built up. So how the terms in a sequence will be building up? By following or by using the rule which actually that particular sequence follows. Right. So with this help of rule, we can find any term involved in the sequence. So once we could able to find that rule which is involved in that particular sequence, so using that rule, we can find any term involved in that sequence. So you can find a second term, you can find a 10th term, you can find a 5th term, you can find a 20th term. So you can find any term involved in the sequence with the help of the rule here. Right. So let's have a look over the example here. For example, here the sequence which is mentioned 3, 5, 7, 9. So let's just observe whether it's a sequence or not. So here total number of terms 4. So it's a sequence and it's a finite sequence. So here what is the rule you can see? So 3 and the next term plus 2 and 5 plus 2, 7 and 7 plus 2, 9. So if I asked you what is the 5th term in this sequence, then you will be, so this is 1, 2, 3, 4. The 5th term will be 9 plus 2, that means 11. If I ask you the next term, 6th term, it will be 13, 15. So likewise, we can find any number here. So what is the rule of this sequence which is mentioned? The rule here is, it is jumping 2 by every time. So every term here is jumping by the number 2. Right. So 3, 5, 7, 9, 11, 13, 15. So likewise, we can write any term which is involved in this particular sequence, as here we are aware of the rule of this sequence. Right. So now let's see the formula here. So if we know the rule, we can actually use that and we can actually formulate the formula for that sequence in terms of n. That is, n can be any natural number. Right. So using the rule here, we'll be trying to formulate a formula for the sequence here in terms of natural numbers n. Right, so here let's see examples. So here we are having one sequence having the terms 1, 3 and 7. Right. So what will be the rule of this sequence here? Again jumps by 2 plus 2 plus 2 plus 2. Right. So I'll take it as 2n minus 1, where my n belongs to natural numbers. So if I substitute 1, then it will be 2 minus 1, 1. Right. So if I substitute 2, then it will be 4 minus 1, 3, second term. So let me take n value equal to 1. Then it will be first term. N value equal to 2, then it is 4 minus 1, 3, that is second term. And if I substitute my n equal to 3, it will be 6 minus 1, 5, which is nothing but my third term. That means when my n equal to 1 in this formula 2n minus 1, that will be my first term. N is 2, second term. N is 3, third term. If I asked you what will be the 10th term in this sequence, then I'll just use my formula here, which is 2n minus 1. I have to find my 10th term. Then my n value will be 10, which will be 2 into 10 minus 1, that is 20 minus 1 equal to 19. So I can directly state here my 10th term will be equal to 19 using the formula which I have predicted here, that is 2n minus 1. Right. So with the help of rule here, we will be able to write the formula for the sequence. And once we are having the formula for the sequence, then we can find any of the term using the formula here. So let's have a formula for the second example here. So this is our second sequence here having the terms, that is 2, 4, 6, 8. So again, what is the rule here? The terms are jumping by 2. So I'll be writing 2n. That's all. Because these are even numbers. So where my n belongs to natural numbers again. So let's take n equal to 1. Then what will be my first term? 2 into 1, that will be 2. When n equal to 2, that will be my second term, that is 4. When n equal to 3, 3 into 2, 6, that is my third term. So similar way, if I asked you to find some 15th term, what will be the 15th term in this sequence of 2, 4, 6, 8? That is nothing but where my n equal to 15 implies 15 into 30. That means my 15th term in this particular sequence, which is given here, is equal to 30. Right. So we can say for any given sequence, once we could identify the rule which is following in that sequence, and then we could able to derive and write the formula for that sequence with respect to, that means in terms of n, where n belongs to natural numbers. Then we will be able to find any term in that particular sequence. Right. So now as we have seen our formulae, rule as well as our sequence. So now let's see the standard notation of this sequence. So that notation Tn is used to represent the general term of the sequence. Right, that means if I'm having a sequence 2, and so on, the general term will be notated by Tn. That means the first term will be notated by T1, second term is notated by T2, third term by T3, fourth term T4, fifth term T5, and we will be having some n terms here. Right, the nth term here will be denoted by Tn. Right, so the representation, the notation we'll be using to represent the terms which are present in the sequence is nothing but T1, T2, T3 and so on, Tn. Right, where n here is nothing but the position of the term in that particular sequence. So this is the 2 is the first, is presented in the first position. So it will be T1, where 8 is the fourth term. So it is notated by T4. Right, so likewise we'll be using this notation in order to represent the terms which are present in the sequence. Right. So before getting into our next concept here, so let's sort out and do few questions related to this sequence part, and then we'll jump into our next concept. So let's have a look here. I hope you guys can do it. So quickly solve this and let me know the answer as fast as you can. So quickly do it. So here, what is the question states here? Find out the first four terms. So you have to represent that in terms of the notation which we have seen and write down all the first four terms in the sequence where the general term is given here. So just now we have seen the general notation of the term is Tn. So the general term is given here, which is minus 1 by n whole power n. So this is the general notation of the general term, which is Tn here, minus 1 by n whole power n. But here you have to find out the first four terms of the sequence. So we have to take the n values. So here n values belongs to natural numbers. We have already seen. So here n denotes the position of the term. So here we have to write our find out the four terms, that is T1, T2, T3 as well as T4. So here this is nothing but n value. So here we have to substitute the n value in the given general term, that means minus 1 by 1 whole power 1, which means T1 here will be equal to minus 1. Right. So let's find out the second term here, that is T2. So here T2 will be equal to minus 1 by 2 whole square. That means negative will be eliminated. T2 will be equal to 1 by 4. So let's go to the next one, that is minus 1 by 3 whole cube. That is equal to minus 1 by 27. And next we are having minus 1 by 4 whole power 4. So it will be 64 into 4, which is 256. So positive, so 1 by 256. So here for this given general sequence, we have to find out the 4 terms which are given by minus 1, 1 by 4, minus 1 by 27 and then 1 by 256. So this will be the sequence which includes the first 4 terms. Right, so just the substitution required here and simplification further. So let's do one more. So here there are 2 more questions related to the same model. So quickly do it and let me know. So here you just have to write the sequence. So there they have mentioned that you have to find out only 4 terms here, but here you have to write the sequence. So just do it. So while writing sequence, it doesn't mean that you have to write all the terms in infinite times, because here it will be obviously an infinite sequence. So yeah, you can write the first 3-4 terms and then last term. That would be enough. So same way how we have done. So here they have given the nth term, that means Tn here for the first one will be equal to 2n, and similarly Tn for the second one here will be equal to log of nx. So let's take the n values. So n will be from 1, 2, 3 here in order to write the sequence. So if n is 1, 2, n is 2, 4, n is 3, 6, and so on until 2n will be the last term here, because that will be the nth term. Right, so this will be the first sequence. Similarly, let's write the second one. N equal to 1, that means log x. 2, that means log 2x. 3, that means log 3x. And so on until the last one will be log nx. That's it. So this will be the sequences, 2 sequences for the given nth terms of the sequence here. So once we have the nth term, it will be very easy in order to write the terms involved in the sequence there. Right. So let's move on to the next one. So far we are discussing about sequences and the types involved in it and the notation and everything. So now let's go into our next concept, that is series here. So let's see what is the difference between the sequence as well as series and what will be the notation for the series here. So series is something that we can get from a given sequence by adding all the terms. That means series is nothing but sum of all the terms which are present in the sequence. So if we take a sequence, how many terms will be having? N terms. So T1, T2, T3 and so on Tn. So these are the terms which are present in my sequence. So here this is a sequence having terms T1, T2, T3 and so on Tn. But here we have to find the series. Series is nothing but simply the sum of all the terms which are present in the sequence. That means T1 plus, T2 plus, T3 plus, T4 plus and so on until the last term, that is Tn here. So this is nothing but the simply sum of the terms which are present in the sequence will be equal to the series. Right, and this series will be represented by Sn. So Sn is nothing but sum of all the terms which are present in the sequence, which is nothing but the series. So here Sn series will be equal to T1 plus T2 plus T3 plus and so on until Tn. So basically here we are having a relation between a sequence and series, which is nothing but the sequence will be having terms with respect to the formulae, notation and everything, and series will be simply the sum of all the terms which are present in the sequence, right? And the series here will be denoted by Sn. So now as we are started discussing about series, so now we are having this sigma notation because series is nothing but sum. So when we are having sum, we definitely be using the symbol sigma, right? So which means the symbol sigma indicates that it is a summation, right? 1 second. So symbol sigma, it's nothing but it indicates the summation of the terms here, right? So for example here we are having sum of first n natural numbers or else sum of first 10 natural numbers or 9 natural numbers. So here in this example you can see. So I already mentioned sigma is nothing but the symbol which will be indicating the summation, right? And this is the symbol which will be used for sigma. And here if we are having sum of terms 1 plus 2 plus until 9. So instead of writing all this, we can write this as sigma, which means it is the sum, right? Sigma n. So n means these are all numbers here, natural numbers, and these are starting from, that means n is starting from 1 here and ends with 9. So instead of writing this entire thing of 1 plus 2 plus 3 plus and so on until 9, we can simply represent that as sigma n, where n is from 1 to n, right? So in the similar way, if we are having 1 power a plus 2 power a plus 3 power a and so on n power a. So this can also be written. So here it is summation. So it will be denoted by sigma. So these 1, 2, 3, these can be represented by our natural numbers. And power a, so a is a common, so we can write it as n power a here. And from where it starts the number n, so n is starting from 1 and it will be going until n. That means n equal to 1 to n. So this is also the representation of sigma, right? So now so far we are seeing from this sum to sigma how we have converted. So now let's see from sigma to our normal thing how we can convert and write that. So if for suppose you are having sigma I plus 1 by 2i plus 4, where I will be equal to 1 to 5, right? So the expansion of this will be I is starting from 1. So 1 plus 1 by 2 into 1 plus 4, first term, and as it's a sigma which indicates the sum, so here it will be plus, after 1 it will be 2. That means 2 plus 1 by 2 into 2 plus 4. Then it will be 3. That is 3 plus 1 by 3 into 2 plus 4. And then 4. That means 4 plus 1 by 2 into 4 plus 4. And the last one, because I will be ending with the number 5. That means 5 plus 1 by 2 into 5 plus 4. So this is how we will be applying and expanding our sigma terms here, right? So simply sigma notation will be applicable whenever we are having this sum of any sequence or any summation related thing, and the symbol which will be used to write sigma is this symbol. So this is the symbol. So let's see few properties here which are related to our sigma, that is summation. So the first property we are having is sigma A, I equal to 1 to k. So here if you see there is no I here in the summation, but here they have given I equal to 1 to k. That means only this A only will be added this k times. That means A plus A plus A plus A plus and so on. That means this k A will be added k times, which will be equal to k into A, where A is a constant here. Right, so there will be small things which we have to identify here while dealing with this sigma. And the next here you can see sigma A into I equal to 1. So multiplication here, right? So if we expand it, what it will become? A into 1 plus A into 2 plus A into 3 plus and so on A into k. That means amongst this entire series A is anyways common. So we can take A common and this will become 1 plus 2 plus 3 and so on k. That means in the sigma itself we can write that. So instead of writing sigma I equal to 1 to k ai, as A is a constant, we can pull out this A out from the sigma and we can write this to be I equal to 1 to k I, which is nothing but the same thing here. Right. So whenever we are having any constant like this, we can directly separate that in the sigma itself without doing this entire expansion. Right. So let's discuss the next property here. So when we have sum, for the sigma, in between we are having plus or minus. So this can be separated again. That means sigma r equal to, so here you can see, so here sigma ar plus or minus b. So here with this plus or minus, we can separate it as two different terms. Then it will be becoming as sigma r equal to 1 to an ar plus or minus sigma r equal to 1 to an pr. Same thing will be for the multiplication here. Right? Right, so these are the properties which are related to the sigma, and first two are very important and three will be most commonly used. Right, so now as we have seen our sigma notation as well as the properties related to that, so let's jump into our next notation, which is a pi. Right, so as sigma indicates the summation, here pi indicates the product of the terms. Right, that is the multiplication. So the meaning of the symbol pi is a product. So the symbol which we use for pi is this, and the meaning of it will be the product of the sequence. So if we want to find any product of the terms which are included in the sequence, then we can simply use this. Sorry, it should be pi here. Right. So here we are having some examples related to our pi notation. So let's have a look here. So same thing. So instead of sigma, we'll be using the pi. When it's sigma, it will be the symbol in between the terms will be plus. When it's a pi, the symbol used in between the terms will be multiplication. So here pi n equal to 1 to 6. So pi n, that means n will be starting from 1. So as it's a pi, it will be 1 into 2 into 3 into 4 into 5 into 6. So in case if we are having sigma n equal to 1 to 6 n, then it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that is the basic difference between this pi notation as well as the sigma notation. So let's see the next one here. So the next one is pi n power m, n equal to 1 to k. So here m is the constant, only the n values will be changing. So the expansion here will be 1 power m into 2 power m into 3 power m into and so on. Here last n value will be k, that means k power m here, right? So the same thing here, n equal to, so pi n equal to 1 to k. So in the first example it is from 1 to 6, here it is 1 to k, that means 1 into 2 into 3 into and so on into k. So here this is nothing but 6 factorial, yes or no? And here this will be k factorial, right? Because it's related to the product here, right? So these are the things related to the pi notation. So far we have seen our sigma notation, pi notation and all. So first we have started with the sequences and the types involved in it. Then we jumped into the rule, formula as well as the notation of the sequence. And then we have learned the series, and when we into series we will be having the sigma summation. So that's why we have discussed here our sigma notation as well as the pi notation. So now let's jump into our next important concept, which is the arithmetic progression here, right? So as I mentioned, sometimes sequence will be called to be an progression, so there is nothing different here. So let's see the definition of this arithmetic progression. So the sequence in which the successive terms maintain a constant difference is known as an arithmetic progression. So basically arithmetic progression is nothing but a sequence in which we'll be having terms, right? So in the successive terms they'll be maintaining a constant difference. So the difference will be same. So if you remember, while discussing our sequences, we have seen example like 2, 4, 6 and 8. So they'll be jumping by plus 2, plus 2, plus 2, which means this is the common difference between the terms and that is constant, which means this sequence here is called to be an arithmetic progression, right? That means the standard sequence of an arithmetic progression will have terms. If we are having a as the first term, the second term will be a plus d. So where d is the common difference here. As we know, common difference is constant. So here third term will be a plus d plus d. And fourth term will be a plus d plus d plus d. That means first term is a, second term is a plus d, third term is a plus 2d, fourth term is a plus 3d. So likewise we'll be having, so this first term is denoted by t1, second term is denoted by t2, third term is denoted by t3 and fourth term is denoted by t4, right? So here we know that a is the first term of the sequence and d is the common difference of the sequence. So now my question is, how we'll be finding this common difference? So if we have the difference of t2 minus t1, that means a plus d minus a, which is equal to d, right? The same thing if we do t3 minus t2, that means a plus 2d minus a minus d equal to d. Right, that means the difference of the terms will be constant and with that will be equal to common difference d in an arithmetic progression, right? So now let's have the sequence of our arithmetic progression. So a plus d, a plus 2d, a plus 3d and so on. So this is first term, second term, third term and fourth term. So common difference d will be constant and that will be equal to t2 minus t1 or else t3 minus t2 or else t4 minus t3. So you have to identify it is the second term minus first term or else third term minus second term, right? So likewise we'll be having the common difference here. So now as we have seen the standard sequence of arithmetic progression and the notation of the terms as well as the common difference here. So let's figure out the general term here. So let's figure out the general term for the arithmetic progression here. So we know general term will be denoted by Tn. So what are the terms here? A plus D, A plus 2D, A plus 3D, and so on. So now we have to predict our nth term, which is the general term here. So Tn will be, so here T1 will be A, T2 will be A plus D, T3 will be A plus 2D. So Tn will be, A will be common, A plus, so here D also will be common. So here we'll be having something. So here you can see 2 minus 1 will be 1, 3 minus 2 will be 2. That means n minus 1 into D. Right, so using the rule here, we are trying to write the formula for this particular sequence. So the formula which we have predicted here for this arithmetic progression is Tn will be equal to A plus n minus D, which is the general term. Right. So once we have the first term, general term and the common difference, it will be easy to write the sequence. Right. So in this arithmetic progression, we should be familiar with three important terms. One is the first term of the sequence, right? And the next is D, which is the common difference here, right? And the other is the nth term, which is the general term of the arithmetic progression, which is given by A plus n minus 1 D, where n belongs to natural numbers. So using these three conditions, we can write any sequence of the arithmetic progression. Right, so let's have a question here. So before discussing the question, we are having few terms related to the general term. So let's have a look over that. So general term is also denoted by L because it's a last term. So there are two representation here. So Tn or L. So both actually denotes the general term. Right. So here n belongs to the number of terms. So that we already know because T1, T2, T3, Tn. So this subscripts 1, 2, 3 and so on n are nothing but the number of terms. Right. So here n will be equal to number of terms which are present in the sequence. Right. So in this arithmetic progression, we will be having three types of arithmetic progression. Right. So one is increasing arithmetic progression. Second one is decreasing arithmetic progression. And the third one is constant arithmetic progression. So all these three will be depending upon the common difference D. Right. So if this common difference D is greater than 0, right, then it's obvious that our sequence will be tending to positive infinity. That means it indicates as a increasing arithmetic progression. So directly we can say if there is a common difference which is greater than 0, then the arithmetic progression will be obviously increasing arithmetic progression, which indicates that the sequence tends to positive infinity. So same thing if our D is less than 0. So it's obvious that when common difference less than 0, it will be tending to negative infinity. That means the sequence tends to minus infinity, which indicates that the arithmetic progression here will be decreasing. Right. And the third case here will be when D equal to 0. when a constant, the common difference d itself a constant, it's a 0, then the arithmetic progression will be a constant. That means I'll be having a. If my common difference only 0, then it will be a comma a comma a comma and so on. That means all the terms will be remaining same, and that progression will be called as constant arithmetic progression. Right. So as I mentioned, entire this arithmetic progression, this first term, common difference, this nth term or last term, as well as the number of terms n. So all these will be very, very important while dealing with this arithmetic progression. Right. So now let's solve a question related to our arithmetic progression here. So I know you guys are familiar with this arithmetic progression. So I hope you guys can solve it and let me know the answer quickly. I'll just check the comment section meanwhile, so that if anyone has any questions, any doubts, you can let me know. So far I didn't get any questions, guys. So I hope you are following the class. So quickly solve it and let me know the answer for this question. So let's read the question and write the given information first. If the fifth term of an AP is 17, that means T5 here will be equal to 17, and its seventh term is 15. That means T7 will be equal to 15. And find the 22nd term. We have to find T22. So first write the general term. So general term will be a plus n minus 1d. So using that, you can directly predict the answer. So write your T5 in terms of general term and write your T7 in terms of general term. That means in terms of A and D. So you'll be having two equations in terms of A and D, and you have to find two unknowns. And n value is already given. So two equations, two unknowns. It's easy to simplify. So here, what is our T5? So let's write down here in terms of nth term. So a plus n will be 5. So 5 minus 1 will be 4. That means a plus 4d is equal to 17 here. Similarly, a plus 7 minus 1, 60 will be equal to 15. So two equations and two unknowns. So a plus 4d equal to 17 and then a plus 60 is equal to 15. So minus 2d and minus 17 minus 15 will be 2. That means d will be equal to minus 1. That means the sequence here, when d is less than 0, the sequence is decreasing. That means here it is a decreasing arithmetic progression. So if d is minus 1, let's see for a, minus 4 equal to 17. A will be equal to 21. So we got the two values a and d. So let's substitute and find T22. So T22 will be equal to a is 21 plus 21 minus 1 will be, 22 minus 1 will be 21 into d minus 1. So 21 minus 21 is equal to 0. So the term 22 in this arithmetic progression is equal to 0. It's as simple as that when we apply our nth term concept here. So let's move on to the next question. So here comes the similar type of question. So quickly you guys can solve it and let me know the answer. So again you can start doing this by taking the nth term, that is Tn equal to a plus and minus 1 into d. Quickly guys, it's very easy. It hardly takes 2 to 3 minutes. So let's read the question. If 11 times the 11th term of an AP is equal to 9 times the 9th term. So first let's write the 11th term. So T11 will be equal to A plus 11 minus 1 10 D. Similarly, what about the 9th term? So T9 will be equal to A plus 8D. So the condition which they have given is 11 times the 11th term. That means 11 times A plus 10D is equal to 9 times this 9th term. That is A plus 8D. So let's expand this. So 11A plus 110D, 9A plus 72D here. Right. So 11A minus 9A will be equal to 72D minus 110D. Right. So 11A minus 9A will be 2A and 110 minus 72 will be 38. So the other side will be minus 38. So this will be plus 38D equal to 0. So this we can take 2 common. So it will be A plus 19D equal to 0 and 2 will become 0 and then 80A plus 19D equal to 0. So here what is the question they asked? They have asked that we have to find the 20th term. So 20th term, that is T20 equal to, according to the formula, A plus n minus 1 will be, that is 20 minus 1, 19D. So A plus 19D. So just now we have derived the condition A plus 19D is equal to 0. That means here the 20th term will be equal to 0. So it's just that we have applied our general term of the arithmetic progression as well as the condition which is given in the question. So we could easily get the answer here. So I hope you guys understood whatever we have discussed in today's session and you could have able to solve the questions. So we have just started with our arithmetic progression. So we'll just continue the rest of the topics related to arithmetic progression and the coming topics of sequences and series in our next session of sequences and series. So I hope you guys have understood today's session clearly. If you guys have any doubts and questions, you can get back to me and you can ask me anytime. So that's all for today. Thank you guys.